potential climate crisis looms in the not-too-distant future. The concentration of greenhouse gases in our atmosphere grows at an unchecked rate. If this trend continues unhindered, big problems lie ahead for us all. We're here to challenge what's possible in the critical decade ahead. Our landmark promise? The Gigaton Challenge. We are committed to help our customers achieve a cumulative 1 gigaton reduction in their carbon footprint by the year 2030. And we are challenging our industry and the rest of the world to join us. How big is a gigaton? It's 1 billion metric tons of emissions. It is equivalent to the entire annual emissions of France, Italy, and the United Kingdom combined. It's a big goal, but we are optimistic and ambitious. The need for climate action has never been more urgent. Bold action has to start now to bend the curve against catastrophic global warming. Heating and cooling buildings, as well as transporting refrigerated goods, contributes almost 1/4 of the total global carbon emissions. To push this curve down, our solutions help reduce the overall energy required to power the critical infrastructure our world depends on. Through innovation, we are advancing technologies to expedite the transition to a cleaner, safer, and healthier energy production future. We've deployed low global warming potential refrigerants and are accelerating clean technologies to address these trends ahead of regulations. With low footprint and connected transport solutions, we reduce loss in the cold chain, ensuring precious resources like food and medicine make it to their destinations and people who need it. Our customers trust us to help them build safer, more resilient, and efficient operations. We know we can meet the call while also providing positive outcomes for the environment. Sustainability is at the center of our business, and we are standing at the forefront of a movement to solve global climate crisis. We are proud to be Trane Technologies.
Hi, everyone, and welcome to this webinar hosted by Trane in partnership with the World Climate Foundation. My name is Dominique. I'm part of the Trane product management team. And on behalf of the full team, I'm excited to have you here and really anxious to share with you some of the technology advancements on air-to-water heat pumps. Now, mitigating climate change and improving the quality of life of citizens can only happen if the cooling and heating sectors come together to challenge what is possible. As part of Trane Technologies, we at Trane are committed to working with our suppliers, business partners, and customers to make the decarbonization of the heating and cooling sector a reality. Throughout this webinar, you'll be hearing from product experts, engineers, and business leaders who will talk us through some real solutions which are readily available on the market and can help us achieve these goals. There will be a Q&A session after the presentations, so I encourage you to engage with us. Post your questions in the chat box that you see on your screen, and we'll come back to them at the end. First, let's kick it off with a brief introduction to explain why we at Trane felt the need to act and why we believe that the future of heating is electric. In 2015, there was a study conducted by the Heat Roadmap Europe project, and their aim was to really understand where and how final energy is being used in Europe. The study found that 50% of final energy demand is used for heating and cooling. And if you dig into this pie even further, you find that the majority of that demand is for space heating. That brings out one of the most obvious things, which is indeed, if we really want to change the course of climate change and start by acting somewhere, you need to start where you can really have a big impact. And this really explains why the heating industry is under immense pressure at the moment to find new ways for it to decarbonize itself. Another particularly important or curious thing that came out of the study is when you compare the magnitude of difference between space heating and space cooling. Now, even though space cooling only represents 1% of demand, this is going to be increasing over the coming years. And it's very simple to understand why. First, we have, thanks to global warming, temperatures which are increasing globally. We also have building envelopes, which are improving, becoming better and better insulator thanks to stricter regulations. And more recently, we've seen an increase in more demand for indoor air quality. And this is driving an increase in cooling, ventilation, and humidity control. So this means that the industry is faced with two challenges at the same time. On one hand, how do we reduce the energy intensity of the heating sector? And on the other hand, how do we prepare for an increase in energy demand coming from the cooling sector? The key to solving this challenge is really quite simple. We need to look at how the two sectors can work together to satisfy that need. And in a couple of minutes, I'll be sitting down with Hugues, who will talk to us a little bit about what that means and how we can understand heating and cooling demands in a building. But first, let's take a deeper dive to understand some real practical challenges that the industry, in particular the heating industry, is facing. So in 2015, on average, 60% of the heating in Europe was supplied by directly burning fossil fuels. And in some countries, that can be as high as 80%. The most common type of heating technology which is used across Europe are fossil boilers. And aside from having poor efficiencies compared to other technologies, they're also responsible for direct greenhouse gas emissions. On top of that, they also emit atmospheric pollutants, which negatively impact the very air that we breathe. So to protect our climate and improve our quality of life, the European Commission has decided to boldly commit to achieving carbon neutrality by 2050. This means that gas, coal, and oil consumption will need to fall to zero by 2050. Now, if you think about a new building, energy efficiency and sustainability, it's always at the core of the design, not just because of new directives and regulations like eco-design, but also because there's an economic benefit of reducing your fuel and oil and energy consumption in general. The biggest challenge for us, for Europe, is in fact the existing building stock. If you think about it, fossil boilers have an average lifetime of 15 years. That means that once a boiler is installed, it is likely that it will only be replaced in 15 years or more. Annually, today, there are approximately 500,000 fossil boilers which are replaced by low-carbon alternatives like heat pumps. However, if we really want to decarbonize the heating sector by 2050, we will need to increase this by 6 times to more than 3 million boilers a year. We cannot highlight enough that replacement decisions being made today are critical to determining our success at achieving our targets and mitigating climate change while we still can. To put it simply, replacing a boiler with a more efficient boiler is not going to cut it. And this is why manufacturers like Trane are working relentlessly to make low-carbon alternatives more accessible and affordable to commercial and industrial installers all over Europe. So what exactly is a heat pump, right? And how does it work? So to put it very simply, heat pumps are essentially machines which use a thermodynamic cycle, which is powered by an electric compressor, to transform energy, in this case in the form of calories, from one medium to another. When a heat pump is in heating mode, which is what is depicted on this slide, it's drawing on renewable energy available in nature. So air-to-water heat pumps, like the ones we're going to talk to you about later, are extracting energy from the ambient air. Water-to-water or geothermal heat pumps will draw their energy from water sources on the ground. And you can even draw energy from other sources that reject a lot of heat, like data centers, for example. Now, independent of the energy source, all heat pumps utilize a similar technology based on pure thermodynamics, which uses a vapor compression cycle to convert those calories into a useful form of energy for the building. In this case, that's heat. Now, the beauty of this thermodynamic design is that we can easily use a reversing valve to simply switch the direction of the cycle. So the same unit, which in winter provides space heating, can now also be used in summer to provide cooling. In cooling mode, the heat pump will instead use its vapor compression cycle to remove unwanted excess heat from the building, which results in a cooler temperature inside the space. That unwanted heat is then rejected by the condenser into the same medium that in the previous slide we defined as energy sources. Now they become energy sinks. I know what you might be thinking. Isn't that a waste of energy, just rejecting heat into the atmosphere like that? And you are right. The rejected heat from the vapor compression cycle can actually be considered an energy source. Using an integrated heat recovery system or a cascade system, we can actually reclaim this energy instead of rejecting it to the atmosphere and use it for other heating requirements in the building, such as the preheating of swimming pools in hotels, post-heating for dehumidification systems, and even hot sanitary water. Understanding how a heat pump cycle works, it should be easier for you to understand the unique capability this technology has to provide comfort heating and cooling for a building. That means that the traditional approach to heating and cooling, which consisted of using a fossil boiler for heating and a separate chiller for cooling, can now be simplified, fully electrified, and integrated into one single piece of equipment that does not directly emit any greenhouse gases, nor does it release nasty pollutants in our atmosphere. If you think about all the work being done through the Renewable Energy Directive and the target to increase the share of renewable energy in our electricity grid, it means that heat pumps are the needed bridge we need to fully decarbonize the cooling and heating sector. Coming up next, I will virtually sit down with our systems application expert, Hugues Dupré, to share some best practices around the design and operation of heat pump systems. See you in a bit. Hi, thank you for joining us, Hugues. So you've spent many years working together with engineers and HVAC designers to design and optimize hydraulic heating installation. So you're my key expert on this subject. But before we dive into what electrification of heating actually means for designers and installers, can you talk to us a little bit about different types of heating demands that may exist in commercial buildings? And what is the most common technology used to meet those demands?
Yeah, for sure. So I think we can say that there is mainly two types of heating requirement in a building. So there are needs related to space heating and those related to the production of sanitary hot water. So the space heating and sanitary hot water needs are present in most of the commercial building. But it's important to understand the difference between them because the constraint to satisfy these demands can be very different. First, you have to understand that the ratio between space heating and domestic hot water depends on the building usage. For example, in an office building, the need for domestic hot water is quite limited and represents only a small portion of the total heat requirement of the building. But if you have a look at an hotel or an hospital, sanitary hot water needs are very significant and generally are produced centrally. Something also very important is the insulation of the building. Good insulation in a building reduces the space heating, but it doesn't have any impact on the domestic hot water needs. So it has an influence on the ratio and potentially on the design of the solution for satisfying these needs. Another important factor, I would say, it's probably the heating requirement. They are seasonal. In the summer, buildings are not heated, while sanitary hot water needs are present throughout the year. So this is a main difference between the two needs. On the top of that, and I think it's probably the most important, is the temperature you have to produce the hot water be different. Sanitary hot water are generally produced between 70 degrees and stored at least 60 degrees to avoid Legionella issue. And depending on the design, a space heating system, they can operate at different water temperature. Before, the system were designed for water at high temperature, like 90 degrees Celsius or 80 degrees Celsius. And this is fully compatible with the production of sanitary hot water. So from a single system, you were able to satisfy both needs. Now, space heating systems are designed for medium or low water temperature. That means with water at 45 degrees or 35 degrees, you can satisfy, I would say, the space heating requirement. But this is with sanitary water. You need two different systems for satisfying these two needs.
Okay, so Hugues, let me stop you there, because it basically sounds like being an HVAC system designer isn't as easy as a job as I thought it was. So there are many, many things to consider. I think we can both agree, though, that the primary objective of any HVAC designer, and let's focus now on the construction of new buildings, right? Their primary objective is going to be to deliver comfort in the most efficient and affordable way. You've talked about two types of heating demands, one which is the space heating, so the temperature, so to speak, and the other one is the sanitary hot water, right? So nobody wants a cold shower all the time. Here's my question, though. When we're talking about a new building construction, one of the first dilemma that an HVAC designer is confronted with is what kind of technology he's going to use, what kind of HVAC equipment. So in your view, what are the main factors or questions that an HVAC designer should ask him or herself in order to guide him or her towards the best technology?
Well, selection of equipment for new building is, I would say, a broad subject. You know, the new building is much better insulated than. So the designer take the advantage, I would say, of this better insulation and solar gain also for reducing the heating needs. And because this heating loss has been reduced, the building heating demand have decreased. So this leads to, I would say, a decrease in the installed capacity and shorter heating periods, because heating systems are started later in the season, when the outdoor air temperature is lower. But this also means that now it's possible to use low water heating system to maintain the thermal comfort in building, even in cold climate. And that means that most of the heat emitter, the terminal unit, the radiator, or all this heat emitter in the building are selected for low water temperature. And in this context, air-to-water heat pumps are particularly efficient for producing this hot water temperature for the heating system. Another consequence of this, I would say, better insulation of the building is that you need to cool earlier in the season. So that means even if the outdoor air temperature is low, you need to cool the building. And what we see, it's in some building, and more buildings are like that, depending on the orientation of the building, some part of the building exposed to the sun need to be cooled, while other part of the building, maybe in the shadow or exposed to the north, need to be heated. And so you have really to pay attention to this simultaneous heating and cooling requirement in the building. Before, in fact, if you want to satisfy both requirements at the same time, heating and cooling system were operated together. And okay, it's work, but it's not really efficient because you heat and cool the building at the same time. And you can find some people telling you, okay, no problem, you can use free cooling for satisfying the cooling need in this case. And it will not cost a lot. First, free cooling is not completely free. And secondly, you reject heat in the atmosphere while you need to heat another part of the building. So I would say that as soon as you have a simultaneous heating and cooling need in a building, it's really interesting to recover and to repurpose this heat. So from the site that needs to be cool and use it for the site that needs to be heated. And in this context, the heat pump really makes sense, and more particularly, the multi-purpose or multi-pipe unit. It's really a unit that is designed for recovering the energy. So I think this is really interesting to understand the recovery potential you have in the building and maximize this heat recovery potential for satisfying heating and cooling. So here, if I would like to summarize a little bit, it's really important to know the heating demand and cooling demand profile in the building. The first thing you have to do for sure is to reduce your space heating demand. But at the same time, you have to design the system, and you start by the heat emitter for low water temperature. And so you will improve the efficiency of the system, because when you have low temperature, you will produce the water, the hot water required for this heating system by using heat pump or multi-pipe unit or multi-purpose unit. And in fact, at the end, you have a very efficient system by combining heat pump or multi-purpose unit, and you satisfy the maximum recovery in your building.
That's really interesting, Hugues. So essentially what you're saying is it all starts with really understanding the demand profile, and you can't just look at heating. We need to look at heating and cooling together, the seasonality of both, in order to understand the opportunity for energy recovery. All right, that's excellent.
Exactly.
That helps a lot. All right, so it's all very easy when we're talking about new building construction, because you can sort of start from a blank page in a sense, and you have a lot of flexibility in terms of choosing the type of technology, if it's air sourced, water sourced, etc. But now let's flip to the other side of the coin and talk about renovation projects. And let's talk about specifically a scenario which is still very common in Europe, which is where you have commercial buildings where the heating today, and we can even focus on space heating for the sake of this conversation, is provided by fossil fuel boilers. So I want to hear a little bit your advice, for those designers and maybe even installers that are that have made the decision to upgrade their heating system and convert to a zero carbon heat pump system. What are the main key system design parameters that they should consider when making this switch in technology?
Yeah, I think this is a very, very good question, and it's important because an important part of the building stock, especially here in Europe, is quite old and has a significant impact on the CO2 emission. So you know that in most of the existing building, or at least old building, the system have been designed for boiler, meaning that the heat emitter have been selected high water temperature, so it's really more difficult to use an air source heat pump in this case to satisfy a heating demand, especially during the coldest period of the year. But it doesn't mean that the heat pump should be discarded, because a heat pump can be considered to satisfy hot water needs in existing building. And feasibility, for sure, need to be assessed case by case, because it really depends on the building, it depends on the condition, and several factors have to be considered. We can discuss the different factors, but to explain simply, I would say that mainly you have to check that you will be able to satisfy the heating needs with the existing terminal unit by using the hot water delivered by the heat pump. If you are not able to do that, okay, you will have to consider different options. Either you consider replacing the terminal unit, or in this case, if you cannot satisfy the heating demand, you could use what we call an hybrid system to satisfy this heating demand. So an hybrid system consists in combining an existing boiler, for example, with an heat pump. And you operate the heat pump during the intermediate season when you have mild temperature. And as soon as the heat pump is no longer able to satisfy the heating demand, you start the boiler. And so, depending on the system, depending on the temperature required, the heat pump and the boiler can work together or separately. Systems are suitable in regions where winter are colder, or sometimes during a renovation of existing building, or simply if you want to reduce your footprint, CO2 footprint, by reducing the number of operating hours of your boiler. So you can see that even for existing building where it seems that heat pump is maybe not the best solution, heat pump can help, I would say, owner and facility manager to decrease their carbon footprint and their environmental impact.
Oh, thanks. Sorry, I was on mute there. And I guess you could also say, depending a little bit on the price of gas versus electricity, it could help them to reduce their overall cost as well of operation. Thanks, Hugo. That's clarifying as well. I have one last question for you to sum it up, because we've talked a lot about design and installation, but there's the whole part that comes after that, which is the maintenance of the system. And especially if you think about heat pump systems, they're built to last for a very, very long time, right? 15 to 20 years.
Yeah.
One question that I receive a lot is around the maintenance of heat pumps and how it compares to boilers. So very briefly, do you consider that a heat pump system is easier or harder to maintain versus a boiler system?
This is a little bit a tricky question, because I don't think I'm neutral for answering this type of question. But I would say boiler and heat pumps are two different equipment for sure. And it's first the current model are both equipped with controller, local interface, and both can interact with building management system. So the interaction between the operator and the equipment are quite limited. And I don't think one is more complicated than the other one to operate. They are just different. No, regarding the maintenance, for sure, both equipment needs to be maintained. And for me, it's a little bit hard to say if one is more or less difficult to maintain. But the advantage of the heat pump is with a heat pump unit, you produce heating and cooling from the same equipment. And therefore, the maintenance is limited to only one equipment by one specialist, instead of two equipment and two specialists if you have a system designed with a boiler and a chiller. So globally, we could say that it's a little bit an advantage for the heat pump in this case. And the maintenance cost should be lower if you have a heat pump based system. Yeah.
That's interesting. So not only is it not really harder to maintain because of all of the controls and interfaces developed, but you raise a really good point, which is you have one piece of equipment which can satisfy cooling and heating demands. So actually your cost of maintenance can actually be lower due to that.
Yeah,
Thanks,
exactly. Yeah.
This has been super interesting. I'm sure we're going to get a lot of questions. So I look forward to seeing you again at our Q&A session at the end.
Yeah, thank you, Dominic. It was a pleasure to discuss with you, and I hope that our discussion will help people to better understand what can be done with a heat pump.
Thanks, Hugo. See you later.
Thank you. See you.
Hi again. I hope you enjoyed our short video. In the next coming minutes, I'm going to take you through some of the new features that we've added to our Trane Synthesis Advantage CXAF range air-to-water heat pump. So if you remember, we started out this whole webinar talking about the fact that space heating accounts for an impressive 27% of the total final energy demand in Europe. Now, what's particular about heating and space cooling requirements is that they're highly seasonal. And that means they depend on many factors which are both internal and external to the building. The need for heating and cooling will depend on, for example, the climate profile where the building is located. It will depend on the occupancy profile of the building or how the building is being used. It will depend on the quality of the insulation materials used for the building construction, and it might even depend on the time of the day. These are all important factors to consider when designing an HVAC system, but they're also the basis of design for our engineers when they set out to design the next generation of air-to-water heat pumps. So when we thought about the new design for our CXAF range, our engineers focused on 3 design pillars. First of all, it's all about efficiency, because one of the core purposes of sustainability is that we want to simply consume less energy to get the same job done. The second pillar is around a reliable operation, because the core purpose of any HVAC system is to provide comfort to a building no matter the conditions outside. Now, the big challenge that comes with all of this, especially for heat pumps, is trying to figure out how we can be efficient and how we can be reliable, but we want to be able to accomplish that across all 4 seasons of the year and be able to adapt the unit's performance and consumption to any kind of demand within the building. Let's start with the high efficiency. Here, the key was to make use of the best available technology known on the market, but that wasn't only going to cut it. We went back to our roots and we looked at optimizing the actual thermodynamic circuit design. We optimized the coil circuit patterns in order to improve refrigerant distribution, and this allowed us to reduce pressure drop, which also increases the heat transfer efficiency. We're using the latest generation of scroll compressors with intermediate discharge valve, a technology which, by reducing the excessive refrigerant compression in a part load condition, can deliver much higher seasonal efficiency. CXAF units also use inverter-driven fans, which are able to automatically adapt to the building load, delivering its best efficiency at part load. And then finally, all of this is not going to be enough if you just have the best mechanical design. You need a unit which is smart enough to make use of all the different benefits of the technologies that we use. That's why the new Trane Tracer unit controller and new software has been revised to make best use of all of these technologies and at the same time improve a phenomena which cannot be avoided in air-to-water heat pumps, which is the defrost cycle. Our unit uses a innovative patented algorithm in order to shorten and reduce alternate defrost cycles to the maximum to avoid any penalty in terms of efficiency for the unit and comfort for your building occupants. What does this mean in terms of numbers? We have been able to accomplish on average an SEER of 4.3 and an SCOP on average of 3.3. What does that mean for you? It essentially means that for 1 kilowatt of energy, electrical energy input, this unit can deliver 3 to 4 kilowatts of output of heating or cooling. So our new Trane CXAF model, thanks for its new optimized for heating design, delivers a COP which is up to 10% higher than the legacy range, and an SCOP, which is the seasonal coefficient of performance, of up to plus 15%. All this by optimizing components, using the best technology on the market, improving the circuit design and the control, and without needing to oversize the machine, which essentially means we do not need to use more resources to actually get more output out of our machines. The second pillar is around reliable operation. In heating mode, air-to-water heat pumps, as we saw before, are sourcing energy from the ambient air. That's right, even when it's cold outside, there's still energy in the ambient air that we can use. And this is fundamentally why heat pumps are classified as renewable energy. The technical challenge for product design engineers, not only for Trane, but all across the industry, has been how wide can you go, meaning how hot can you deliver the water, and then how low can you go, which means how reliably can your machine work even when it's extremely cold outside? The capability of a heat pump is best expressed through its operating map, like the one that you see here depicted on your screen. This is the typical operating map of an average air-to-water heat pump designed for space comfort applications. It shows that the capability of the heat pump to provide hot water, which you see on the bottom axis, is highly dependent on the outdoor air temperature, which you see here on the left. The leaving hot water temperature depends on the application and the type of installation. For space heating, we can think of three typical applications: floor heating with temperatures averaging between 30 and 35, fan coil units with hot leaving water temperatures averaging between 40 and 45, and finally low temperature radiators, perhaps one of the most common terminals that we see in the renovation market, which require a high leaving water temperature between 50 and 55 degrees. Typically, floor heating and fan coil units could operate at full capacity between -5 and -15 degrees of outdoor ambience. The challenge came with radiators. This limitation of not being able to deliver high hot water temperature when it is low temperature outside created the perception that air-to-water heat pumps are only suitable for Southern Europe and Mediterranean climates. Well, at Trane, we wanted to challenge this belief. And after the unit redesign, we conducted months of testing in our high-tech R&D lab in northeastern France to really push and test the units to the limits. The result was this. Thanks to the new heating optimized design of Trane CXAF heat pumps, air-to-water heat pump technologies can now benefit from a wider operating map. If we focus again on our key floor heating and fan coil unit applications, we can now deliver the required leaving water temperature as low as -18 degrees of outdoor air ambient. Even for radiator applications, we can go as low as -10, which essentially reduces the need for a boiler all across the winter season. But there was another benefit of a wider operating map, and this is the air-to-water's heat pump's ability of being able to produce up to 65 degrees of leaving water temperature. What that means is that if you have a heat pump installed, if you don't really have a cooling need in your building during the summer, you can simply use this heat for free for domestic hot water purposes, for example. So in a hotel, that could be for showers, for preheating of your swimming pool, and other applications like that. So that is really just talking about the innovation around the heating map. Now, if you combine that with the wide cooling mode map, which enables the heat pump to work efficiently as a chiller up to 50 degrees of outdoor air ambient, you see a heat pump which is able to provide reliable operation all year round, from 50 degrees down to -18 degrees Celsius. Just a quick example, here a project which took place in the Netherlands, a very big museum. This was naturally a renovation project. This building used to have a gas boiler in place, which was used for space heating and sanitary hot water. And the design hot water temperature requirement was 65 degrees at -10 ambient. We were able to help this museum fully decarbonize their heating system, even with such a high leaving water temperature requirement. How did we do that? With a cascade system. The air-to-water CXAF heat pump has been used to predominantly provide space heating to the whole museum, with leaving water temperatures of 35. Then, in order to be able to boost the temperature of the water for the sanitary hot water production, it's been cascaded with a smaller water-to-water heat pump, which is 4 times more efficient and allows the new museum to fully decarbonize their heating and cooling system. Coming up next, I'll pass it on to my colleague Ronald Herbst, who will take us through some of the new innovation features coming to our air-to-water multi-pipe heat pump units. Stay tuned, and I'll see you at the Q&A session.
Facing unprecedented climate change, we must all challenge what's possible to make our world sustainable. Our society demands that we act bolder and take steps to positively influence our climate and our planet. Regulators raise the standards to increase energy efficiency and decrease emissions. And buildings have a critical role to play, since buildings are one of the most energy-intensive sectors. Considering that today most European buildings use gas or oil boilers for heating, and that improved building insulation has created longer overlaps of cooling and heating needs, we at Trane are committed to innovating with new technologies and using renewable resources available in nature as part of our contribution to mitigate climate change and reduce carbon footprint. Over decades, we've partnered with building owners and facility managers to understand their challenges and explore exciting opportunities, such as repurposing untapped thermal energy within buildings. Now, by leveraging new technologies and challenging our industry's way of thinking, we've designed climate-friendly HVAC solutions that repurpose that free energy to balance and fully satisfy any possible combination of cooling and heating needs. Pushing the boundaries of what is possible, Trane introduces its fourth generation of multi-pipe units. Synthesis Balance makes it possible to replace a fossil fuel boiler and chiller system with one centralized water-based unit that can deliver both chilled water and hot water for your entire HVAC system. It features 3 operating modes to provide cooling in summer, heating in winter, or simultaneous cooling and heating year-round. Designed to capture and repurpose free energy available in the outdoor air and to repurpose all the waste heat from the refrigeration cycle, Synthesis Balance leads the industry in performance and efficiency. A unique multi-pipe unit that can be used in all European climates. To achieve this performance, Synthesis Balance features premium components that reduce energy consumption and comply with the latest efficiency regulations, and the innovative Trane adaptive refrigerant system that works seamlessly with the latest unit controller to provide the highest performance in all operating modes and conditions, while keeping a perfect balance between efficiency and operating costs. And because we know that every building has unique needs and constraints, our diverse portfolio allows us to deploy integrated solutions to support building owners' goals, no matter how ambitious. Trane engineers will partner with you to design the optimal combination of products, controls, and services. And our network of highly skilled service technicians will support you from startup and throughout the lifetime of the installation, both for permanent solutions and for temporary needs through our rental services. As part of Trane Technologies, our commitment is to challenge what's possible for a sustainable world. Are you ready to join us?
Good afternoon, everyone. My name is Ronald Herbst. I'm a Senior Product Manager for air-to-water-based heat pumps and multi-pipe units. And it's my pleasure to explain you in the next 6 to 7 minutes a little bit more about, let's say, the unique concept of the multi-pipe units. In this specific case, so-called 4-pipe units. I hope all of you watched our 4-minute video. Because that one is providing you a good overview of a number of heating products that are specifically developed to accelerate the transformation from fossil fuel-based heating systems to electric-driven heating systems. But before we go into, let's say, the details of the multi-pipe units, it's better to take one step back and look to where innovation really starts. And that is with understanding the demand. So the graph that you see here in the middle of the page is what we call a simplified seasonal energy demand profile. In blue, you see the chiller. In red, you see, let's say, the gas boiler line. And as you can see, it's a kind of sinus shape. During the year, from January up to the end of December, you see that usually in the mid of the winter, the demand for heating is at 100 or very close to 100%, and the demand in most buildings for chilled water is at very low levels. When the months, let's say, start to progress, so when we come, let's say, to March, April, and May, in many buildings across Europe, you see that there is an overlapping demand for cooling and on the other side for heating. And the same you see happening, let's say, in the autumn, usually starting later in September and going up to the month of November. So there are a couple of months in almost all countries and in almost all the applications where you see an overlap between cooling demand and heating demand. Traditionally, we have separated the gas boilers or oil boiler plant from the chiller plant. So, but when you think about this meant, and this still means in many existing buildings, that we, as Europeans, for a number of decades, and it's still ongoing, that we are running our chillers and our gas and oil boilers at the same time. And that is really a very interesting concept when you think about, let's say, wasting energy. So how can we reduce that, or how can we better use, let's say, the primary energy that is being used? And energy recovery, as we all know, is always a very good form of saving energy. So in the YouTube video that you just watched, you saw, let's say, this picture that you see on the top left, which is, let's say, the multi-pipe unit. It's an air-to-water heat pump with the capability to go up to total heat recovery. And it has 4 pipes. It has 2 chilled water pipe connections, and it has 2 hot water pipe connections. It's in fact a merge of a traditional gas and oil boiler with a traditional chiller. So you go back from 2 units into 1 single unit. And that 1 single unit that is able to provide cooling and heating in the 3 different operating modes. Keep this in mind, because with multi-pipe units, the unique concept is really that the unit can function as a chiller. So that is operating mode number 1, providing cooling. There is the operating mode number 2, which is heating only, comparable to a traditional heat pump. But on top of that, there is a 3rd operating mode. And that is when the unit starts running in the simultaneous cooling and heating mode. And that allows you to go up to full heat recovery when the unit works in this 3rd operating mode. When the unit runs in the heat pump mode, so in the traditional air source heat pump mode, it makes optimal use of renewable energy source, in this case the ambient air. So it's free energy, free heat, that is absorbed by the refrigeration cycle and going to be reused to provide hot water. When the unit runs in the 3rd operating mode, so the simultaneous cooling and heating mode, then it makes use, let's say, and it optimizes the regain of energy from the cooling process, and it entirely repurposes that energy and transforms that energy or heat into, let's say, hot water. And as we talked about in our video, it's a full electric unit. So there's no gas pipe connections. It's only an electric-driven unit. And that unit gives you the possibility to operate in the summertime with ambient air temperatures up to 50 degrees. And in the wintertime, it can even run in its cooling mode down to -20 ambient air. But usually on the projects that are attractive, let's say, to think about the multi-pipe unit concept, below a certain ambient air temperature, the unit is mainly going to be used, let's say, to regain that heat from the cooling process and repurpose it, or to switch entirely into heat pump mode. So as you can imagine, this is an excellent piece of equipment to decarbonize heating systems, both for new applications, new buildings, as well as for the existing buildings. On the right, you see a city center, and I think we all know, let's say, that panoramic view. And you see all the smoke coming out of the exhaust pipes, out of the chimneys. While you are moving away, let's say, from the application of gas boilers and oil boilers, we will no longer see in the future chimneys, and we will not have, let's say, all kinds of emissions directly in the city center. And when the grid is, let's say, fully powered with renewable sources, at the end of the day, it means that there are no carbon emissions anymore. So there is a new ratio which has been introduced a number of years ago to express, let's say, the efficiency of these products. So you see here on the left, you see the same graph coming back. And as you can see, if the unit runs, for example, in January, and it would run in pure heat pump mode, it will probably reach a COP, coefficient of performance, of 3.3, maybe maximum 3.4. And the same is in the middle of the year, when the unit just runs in the cooling mode, as a traditional chiller, an EER, an energy efficiency ratio of 3.0, maybe up to 3.2. That is, let's say, a little bit of, let's say, the industry standard. But as you can see, as soon when, let's say, there is an overlap between the cooling demand and the heating demand, you see there in the middle expressed TER equals 8. TER stands for the total efficiency ratio. And it's defined as the net cooling capacity plus the net heating capacity divided by the total power input of the unit. And as you probably can well understand, the highest TER value, so the highest total efficiency ratio, is when the building cooling and heating demand are in well balance. That can be at full load, so maximum cooling demand and maximum heating demand, so that you can fully, let's say, recover the heat from the cooling process and reutilize that for the production of hot water. Or it can be at part load, for example, when the unit runs at 60% instead of 100%. With our unique designs, which embed also a dynamic receiver, which I will start talking about a little bit later on, the total efficiency ratio of the fourth generation multi-pipe units, our fourth generation, can go up to 8. So when you think about this, and you take a real unit example, so one of the, let's say, the models that is available in the portfolio, you can generate with only 128 kW of power input, you can deliver more than 1,000 kW of simultaneous cooling and heating. So that's remarkable, because think back about the ER or the COP that I just mentioned and show here in the graph. A chiller, you can only generate approximately 3 kW with 1 kW of electrical power input. And when the unit runs in heat pump mode, so in full heating mode in the winter, it's 1 to 3.3. So the big benefit of this concept is that in many, many applications, existing buildings, new buildings, especially when you see there is quite a significant number of weeks or months when there is an overlap between the cooling and the heating demand, this unit can really, let's say, be a very sustainable solution for that specific building, that specific application. So it's in fact sustainability at its top at the moment. There's today no other air-to-water heat pump available on any of the European countries or markets that can generate more cooling and simultaneous heating based on a certain amount of, let's say, power input. I talked very briefly about, let's say, the dynamic receiver. Well, the dynamic receiver is something that we patented It's an invention from our, let's say, key engineers, and it's patented. And it varies the refrigerant level in the refrigeration cycle. And that depending the unit operating mode. In fact, what it is doing, it is truly optimizing the refrigerant charge in the active refrigeration cycle via the subcooling control. And for that, it uses algorithms to see in which operating mode, which ambient air temperatures, which water temperatures are requested, and then it starts to optimize automatically. It's a key design feature, and this key design feature makes it possible to improve efficiencies at any part load and the full load operation of the machines. And it allows, let's say, to expand the unit operating map in the 3 different operating modes. And as I will show you on the next slide, this patented dynamic receiver design also allowed us, let's say, to supply hot water with a temperature of up to 52 degrees Celsius at a -10 ambient air temperature, which is unique when you look, let's say, to the actual available heat pump machines on the market. So let me show you how you can really think about concept where it could be a great fit. And so these are what I show you here. In the middle is the operating map in the heat recovery mode. And as you can see, in the heat recovery mode, the hot water temperatures can even go up to 68 degrees Celsius. And in the middle of the heat recovery operating map, you see these red dots. Just pick one example, for example, at +8 and +48. And that's an education facility. So what is so attractive, let's say from an education facility, to think about a multi-pipe unit concept? Well, in many universities, for example, you see that there's simultaneous demand of cooling for the research laboratories, while at the same time, in the autumn and in the winter, there's a heating demand to make the students comfortable in the library and or in the classrooms. So, and as you can see, we are well, let's say, the dot is well in the middle of the heat recovery operating map. So the machine will have no issues, let's say, to deliver both simultaneously. Another example is, is the hospitals that you see on the top right, where there is a simultaneous cooling demand of the IT server rooms. And at the same time, you want to reuse that heat to warm up the patient's recovery rooms. So I will not handle all of these examples, just these 2 I'm explaining a little bit more about. But as you can see, in quite a lot of, let's say, different vertical markets, education facilities, hospitals, the hotel industry, the theaters, there's a very attractive potential, let's say, to think about multi-pipe unit concepts and fully regaining the energy and reusing the energy to provide hot water in those specific applications. So this brings us, let's say, to the last slide of this small presentation. And this goes back, let's say, to understanding the real demand of a specific building application. On the top left, you see a photo of a beautiful luxury hotel at the Italian Riviera. As you can see, it's an older building. And so we are talking here about, let's say, renovation of the HVAC plant. Originally, this building was heated with gas boilers, but there was a strong desire from the building owner as well as from the consultant to move away and to transition to a new alternative way of cooling and also heating of the building. The hotel itself has 120 guest rooms. There's a lot of, let's say, conference rooms, and in addition, there's a spa, a gym, and a large indoor swimming pool. And as you can imagine, this mix, let's say, of usage requires all year long comfort cooling and comfort heating. So the choice was finally made to work, let's say, with a hybrid system where we put next to each other in hybrid an air-source multi-pipe unit and an air-source heat pumps, resulting in, let's say, the supply of chilled water of 7 degrees and the supply of hot water to the building of 45 degrees. In the springtime and in the autumn, the multi-pipe unit is, let's say, the leading unit for providing the cooling and the heating. There is, during those seasons, spring and autumn, there is still quite a lot of, let's say, cooling demand for space comfort. And at the same time, there is also a pretty strong demand, let's say, for preheating the indoor swimming pool water. And as you can imagine, we calculated the system in such a way that there's a very well balanced between, let's say, the cooling demand and the simultaneous heating demand. In this case, for preheating, mainly for preheating the indoor swimming pool water. And due to that, for a number of years, a number of months over the year, the customer is able to have a system in place that has a total efficiency ratio of, in this case, roughly 7. So when you think about, let's say, where we come from a gas boiler concept, you can now imagine that this is really contributing a lot to decarbonizing the heating system of this very nice luxury hotel. And at the end, that whole package delivered a very drastic improvement of the HVAC system efficiency. And with that, I would like to hand it over to my colleague, Guido de Sanctis, who is our services business leader, and he will further brief you on how we can, let's say, accelerate the transitioning to more decarbonization of buildings. Thank you very much, and I hope you really liked the presentation. Feel free to raise any question later on during the Q&A, and Guido, the floor is yours.
Okay, well, thank you for joining me today, Guido. I'm anxious to hear your thoughts as a service leader on how services play a role in the electrification of heating. So first question I have for you is that we hear a lot of stakeholders today, even the European Commission, talking about heating as a service. So what does that mean for you, and what does it mean for building owners?
Well, yeah, there are many things you can say about heating or everything as a service, but the way I look at it is really a shift, in mindset when it comes to equipment and the service that this equipment is providing. So essentially, you're moving from owning a piece of equipment, delivering a certain service, such as heating, it's a service, to really pay for the service itself. So thinking about some examples that are closer to us, I always think to cloud storage, data storage. So think about some years ago, we don't need to go too much in the past. You were having a problem of backing up photos and data in general. You were going to buy a hard drive, and then load your photos into the hard drive. And then after a certain moment, your hard drive was full and you had to buy another one and, think about how to transfer data from one to another. I'm sure that you're familiar with that type of feeling, right? And most of the time, or many times, you had to also experience some data losses. Because you were not like a professional hosting data and so on. When you look at the situation today, nobody's buying any more hard drives to do backups locally, but you are buying a subscription to a cloud service from many providers. And what you buy with that subscription is essentially a professional service with people that are, from a core business perspective, taking care of data for you. And you don't need to think about, the risk of losing data. You don't need to think about purchasing a newer drive, transferring data from one side to the other. So it's really, a service that you're buying, and you're getting the service you actually need without the equipment. So heating is a bit the same, is about the same, because if you think about a building owner, what does the building owner needs? I mean, does he need to own the boiler or the heat pump, or does he need the heating service that the boiler or the heat pump are providing, and the comfort of his building? Probably that's what he needs. He needs the comfort, he needs the heating, not the equipment itself. So exactly like the cloud services for data storage, when you move to an equipment as a service for heating, you are getting the same type of positive experience, which is the peace of mind. By peace of mind, heating is going to be provided by an HVAC specialist, like data storage is provided by data centers and cloud data specialists. That's it, the way I like to say it.
Okay. So we're moving towards like a utility-based business model?
Yes, correct.
Okay. If you're, how can this moving towards a utility-based business model for your heating and your cooling actually help environment then?
Yes. Yeah, that's another interesting concept, that we can explain, or we can try to give an answer to. And most of the ways, because there are many ways in order to help the environment with the type of equipment as a service model, are connected to the fact that you are going to be, in an easier position in order to increase your efficiency and reduce your carbon footprint by adopting new technologies, such as heat pumps, electrification of heating, renewable heating systems, and so on. If we think about the current baseline, so the word of today or of yesterday is that people are buying equipment, they are buying boilers, they are buying heat pumps. And when you do that, you need to think about the lifetime of this equipment and the lifespan of your investment. So typically, thinking about heating systems, we can refer to a 10 years, 15 years life expectancy. So that means that the moment you buy equipment, you will be sticking to that equipment for 10, 15 years. And so the efficiency level as well of your heating plant is going to stay fixed, or even get worse during the lifetime of the equipment, which is 10, 15 years. Now you know that technology moves to a very much faster pace. Again, you can think about data storage and cloud technology and so on. But even if you think about heating, boilers, heat pumps, there are new compressors coming out. There are new technologies coming in. And when you move to this kind of heating as a service or equipment as a service model, you are actually, as a customer, always in the possibility to opt for a new, better service. And this new, better service can be greener, more efficient technology, heating system. And this is reducing your energy bills, But as it reduces your energy bills, and that's where the environment starts to become, a part of it, you're actually reducing also your carbon footprint. And that's, of course, for the good of the planet. Sometimes, people might think about, and what happens with the old equipment, because, it looks like we are increasing the renewal rate of heating systems in the world. So that's true. That's what we want to do in order to raise the average efficiency of the equipment and increase reduce the CO2 footprint of the heating equipment in the world. But the old equipment is not something that goes to waste, because essentially, as the heating is provided by a professional company like ours, like a rental company like ours, the boiler or the heat pump that we are going to replace, they stay as property of our company, of the rental company. And we would taking care of reusing that, repurposing it, for example, for short-term needs, where efficiency is not so important. Yeah. Or, worst case scenario, if we have really to scrap or dismiss the equipment, we would do it, recycling in the most effective way, following a bit the principles of circular economy, sharing economy. So I think those two aspects, the sharing circular economy and also the increased average efficiency of the installed park of heaters are actually very good for the planet when you switch to this business model.
Mm-hmm. Right, and the way you explain it, it really makes sense. Okay, so this business model then typically and usually is really applied to the residential setting. We hear a lot about this sort of thing in the residential setting, but and it's focusing on homeowners as the consumer. What about building owners? What about industrial plant owners? Does this also make sense for them?
Yes, for sure. I think for the private owner, now we spoke about the peace of mind, and that's something applicable also for industrial or commercial owners. But on top of that, I think another aspect that comes into play for people that are running a business is actually the risk associated to fixed cost. Yeah. So as a business owner, especially in those rough times now with the situations we are living today, a lot of uncertainty, having a lot of fixed costs, such as owning an equipment which is depreciated every month, is something that can be a threat for your business, because you cannot actually switch it off in terms of costs. In case you need to, switch off your business. And we know it happens in several cases in those days, with restaurants that are forced to close, shops that are forced to close, and so on. If you have fixed costs, you will continue to pay those fixed costs every month. So what happens when you actually go to an equipment as a service model, you're actually going for a pure variable cost situation. Meaning that from the point of view of paying for what you use, you can actually switch off and opt out of your agreement in case your business is turning down or your shop is closed and so on. So that helps, of course, in those rough times. Also, when you look at the budget, yearly budget for equipment maintenance, repairs, and so on, it's an important element of a company budget. When you own equipment, you are making a provision about the risk, a certain risk that something can go wrong. But that's, depends a lot on the risk, on the situation. It's, it's not something that is predetermined at the beginning of the year. So for a business owner, also having a predictable budget is very important. And that's also something that comes with equipment as a service, because in this case, your equipment is available to you at a fixed fee, monthly rate. And then in case of problems, actually the risk for repairs and the costs associated to that are all on the rental company that is providing you the service. So that helps a lot. You see, the predictability of budgets, the variability of costs versus the fixed cost. It's really helping to match with this dynamic situation we are living today, and that's very important, I believe, for business owners. Probably less for home owners, but yeah, right. For industrial owners, very important for commercial owners.
You really need extra flexibility.
Yes, absolutely. Okay,
great. Well, now Trane has launched recently a service called Trane Easy, EAASY. Can you explain what this stands for, first of all, and then what it is and how it's different from the conventional rental service that we've known for years now?
Yeah, so Trane Easy is exactly what we have been discussing so far. So it is an equipment as a service offering. And it covers all the portfolio of Trane products, so it includes also heat pumps for sure. And it differs. It belongs, if you want, to the rental services business that we run. It differs from the normal, ordinary rental business because the rental business essentially people are associating it with temporary needs, such as an equipment breakdown that needs to be compensated somehow. And that's also the way we started years ago. So that's the normal type of business we have. Then Easy is actually our long-term offering. The long-term offering in the form of equipment as a service has for sure a better and more interesting pricing, because the customer is engaging for a longer period. We know that the equipment is going to be there on site for a longer period, so we are able to make more interesting prices compared to the short-term, emergency situation. And then the benefits for the customers and the value proposition is exactly what we have been saying so far in our question sessions. So essentially, you have predictable costs, because those are related to the rental fee, the monthly fee. Customers are getting a full warranty coverage that lasts and extends for the full duration of the agreement. So you make an agreement for 9 years, you will be having a warranty for 9 years included in the price. And also the professional maintenance from Trane Rental Services is included. So that's all, about the peace of mind, about the predictability of the budgets, as we said. And also, Trane Easy is able to deliver this extreme flexibility that we have been talking about. So opting for a larger machine with higher capacity, opting for a better technology, more efficient machine is also possible.
More recent?
More recent, yeah. Mm-hmm. And that's totally different. You see, from the typical engagement that customer will have with a 10 or 20 years time horizon when they purchase an equipment, hopefully from us anyway. So at the end, it's something that, as we said so far, is good for the business, in the ways that we've been talking about so far, and also for the planet, because again, by increasing the average efficiency, by allowing customers to switch to a better efficiency technology, they actually reduce their CO2 footprint. So, the name Easy, I find it quite, nice. And in a catchy phrase, what we say is Trane Easy, it's HVAC made simple. So I hope that also giving you the same type of feeling, because that's what we want to transmit to our customers. We take care of everything. The rest is for you.
Total peace of mind.
Absolutely.
Okay, well, I think we've covered the subject very well. Thank you very much, Guido.
It's a pleasure.
And I think we're ready for question and answer session right now. So thanks, you.
Barbara. Stay safe.
Good afternoon, everyone. My name is Geraldine Vellner, and I'm the communications leader for Trane Technologies in our EMEA region. So we're joined by our panel of presenters this afternoon, and we would like to answer any questions that you have in the next 10 minutes or so that we provide for questions. You can do so by adding questions into the group chat, so that you can see at the bottom of your control menu. Group chat, and I just ask any of the panelists to just mute your line if you're not speaking, and we'll hopefully give the best listening experience to our audience. So with that, we will start by just seeing in the group chat already what questions have come up, and we'll also address one or two of the questions that came up after our webinar or our fireside chat that we did as part of the World Climate Forum Europe series on the 17th of November with our President of Commercial HVAC EMEA, Jose Lalogia, and also Thomas Nowak, the Secretary General of the European Heat Pump Association. So the first question we want to address today is from Vinay. Thank you for your question. And I'm going to put this one forward to our panel member Hugues Debré, who you heard from earlier. And the question is, heat pumps versus traditional systems. Can you explain benefits on CapEx and OpEx?
So, sorry, Geraldine, can you repeat the question because I didn't hear you well?
Sure. So the question is heat pumps versus traditional systems. And then can you explain the benefits on CapEx and OpEx? So when we're choosing between for heat pumps versus traditional systems, what are those benefits from a CapEx and OpEx perspective? And of course, Hugues, we can ask you to respond, but if any of the other panel members would like to add to what you say, they're welcome to do so.
Yeah, sure. It's maybe more a question for Guido, because I think this is a subject that has been covered by Guido. But as Guido explained, probably with the current situation, some customers don't want to invest within the new HVAC installation, and they prefer to rent, to have a long-term renting. So what we see is currently the market is moving to long-term rental instead of investing for a long period into their own equipment, and they prefer to have the service of renting an equipment with all the service associated, meaning the maintenance of the equipment. So they are a little bit more free to decide and to invest, I would say, in something probably more important.
Thank you, Hugues. And maybe Guido would like to add anything to that, on top of what you've already shared earlier today, of course.
Well, what I can add from my side is that, heat pumps are more expensive in general compared to boilers when it comes to a CapEx approach. So that sometimes can be perceived as an entry barrier for the technology. And that's where indeed the equipment as a service, easy or heating as a service can be very, very useful, because actually you stop the discussion. You don't make any discussion about payback and, will my investment pay back into 3 years or 4 or 5? You just pay a certain fee, which should be, of course, reasonable and interesting for the person, for the customer, and you can start enjoying since the beginning the OpEx saving in this case, knowing that at the end of the day, I mean, if the system is properly designed, the operations of the heat pump would be cheaper compared to the boiler's operation in this case. So you will be starting saving some operating costs as you go, as you start renting.
That's great, Guido. Thank you very much. I think that gives some good insight to everyone listening. We have another question, which is, when you keep heat pumps on electricity, you increase load on grids, and that leads to increase in CO2 as we kept those grids loading. And then the question goes on to say, it's kind of using fossil fuels to burn the fuels and create more CO2. I guess it's more of a comment maybe that was put in than a question. I guess at the end, the person is saying it's the same coin with two different faces. Can we please explain? So I think this is a really interesting question, especially when we think about our goals towards sustainability and decarbonization. So I'll just pause and see if there's somebody on the panel who would like to take that question around, what the impact is on CO2 when you increase a load on the grid using heat pumps for electricity.
I can take that, Geraldine, no problem. It does tend to be. Oh, there seems to be a bit of a lag. All right, Ronald, H before beauty. I will let you go.
I think. Thank you.
Okay. So let me briefly share my thoughts here. Because what we see happening today is that all the pieces of the puzzle start to fall together. You very well explained that due to the better quality of the buildings, the demand for heating and cooling has changed over time. So that allows us, let's say, to install heat pumps and air source multi-pipe units. But indeed, these units, they operate with electricity. And the electricity is generated somewhere. But what you see in more and more regions across Europe is that there is already the possibility to have electricity generated with 100% renewable sources. And we all see, across Europe, how much pressure there is, also political pressure, to move very fast away from, let's say, the fossil fuels to, let's say, the full renewable sources and the electricity generated with that. So that's why I say, the pieces of the puzzle, they start to fall together, and it moves much faster than what we have estimated a couple of years ago. Dominique already mentioned about the Renewable Energy Directive. You see a lot of pressure on, let's say, all kinds of emissions on the electricity generation side, and not only, let's say, carbon emissions, but more than that. So what we expect for the coming 10 years, 15 years is a very drastic shift to, let's say, an electricity grid that is for a large percentage based on renewable sources. And I hope this gives at least a little bit of insight. Geraldine?
It does, Ronald, and we'll check if Dominique wants to add anything else.
No, I think Ronald answered it perfectly.
Ronald, I was just saying, I think he did. Okay, thank you, Dominique. I agree with you, and I think you really emphasized the way that we'll be able to change the impact on climate change through ensuring that everything we're doing is as much as possible through renewable resources. So very, very inspiring. And let's see, there are a couple of other questions coming in. So I'm just going to pull up the next one. So the question coming in from Xiao is, does this chillers produce hot water by recovering heat from the discharge side of the compressor? So I'll just repeat the question. Does the chiller produce hot water by recovering heat from the discharge side of the compressor? So I'll just see who would like to take that question from our panel members.
I can take it, Geraldine. I know there's a bit of a lag on the sound. So yeah, João, good afternoon to you too. So both Trane chillers and heat pumps have the capability of producing hot water, and they do this, as you say, by recovering the waste heat during the cooling cycle, and this is recovered from the discharge side of the compressor. So indeed, if you have a need for hot water and at the same time a cooling demand in your building, this kind of option can be very, very attractive to you and help you to save energy and costs.
That's great. Thank you, Dominique. So I'm just checking to see if there are any additional questions after that last one. And it seems that we've answered the majority of questions in the chat. So just an invitation, if anyone in the last couple of moments has any other ones, we will try to answer one. But one that came in after the fireside chat, and Dominique, this is one for you. Could you tell us, what does Trane see as the future development of CMAF and CXAF? So where you see the future development heading towards? I think we've touched off it briefly, but would love to hear your vision on that.
Sure, Geraldine. Great question. People are always looking to the future, and unfortunately, I can't give away all our secrets. You'll have to tune into the next webinar. Two key things that I can say. So one is, at Trane, we continuously look at ways to simply improve the efficiency of our units. And this goes all the way from how can we consume less electricity, make our machines greener, so emit less carbon emissions. But we even look at things, how can we consume less resources, right? Materials, how can we make them lighter, smaller, etc. So that's one thing that we will continuously look at, and how we can improve our products. The second big pillar, which a lot of people are talking about, is naturally the use of refrigerants, so low GWP refrigerants. And this is another way of us committing to lowering our greenhouse gas emissions. So at Trane, we are now relentlessly working to convert all of our chillers and heat pumps using a scroll compressor to a lower GWP refrigerant. I think, Geraldine, now I'm going to actually pass on the ball to Ronald because I know that he likes a lot to talk about our refrigerant choices. So maybe, Ronald, you can share a little bit with the audience what went through our thinking when selecting our new low GWP refrigerant.
Yeah, okay, thank you, Dominique. Let me indeed add something here, and it's one of our favorite topics indeed. That is the next generation of refrigerants. While making our choices, we always, let's say, have to take a very balanced approach because we are talking here about potentially direct emissions of the greenhouse gases. But more important is, let's say, from an equipment perspective and a systems perspective, is, let's say, the indirect emissions. So this brings us back to the point that you very well, let's say, presented earlier. The majority of the greenhouse gases are generated, let's say, by the cooling and the heating that is provided by the equipment. Either it's the heat pumps or the multi-pipe units. And that represents approximately 98–99% of the greenhouse gas emissions. If, let's say, the electricity grid is still, let's say, fossil fuel powered. So that's the key priority. And then next to that, there's another very important element when we make choices for next generation refrigerant. That is the availability on the short term, on the longer term. That's the cost of the refrigerant on the short term and the longer term. And last but not least, let's say, the safety for all the building owners and all the people that are, let's say, remaining in those buildings, as well as for our own service technicians. So we keep on balancing that. And that's how we make a choice for, let's say, a next generation refrigerant. And indeed, like you said, we are very close, let's say, to introduce a successor of the R410A in our heat pump products. And that will be the R454B, because at least from our perspective, it has by far the best balance between everything. And it allows us to level up the efficiency of our products already today, but also, let's say, with the other goals that we have, let's say, a little bit on the longer term in 2023 to go up with another 10 to 12%. So I hope this provides a good, solid answer to the question.
Thank you, Ronald, very much. And we have had a couple of other questions coming in, and I'm also conscious that we are due to come to the end of our session. So we will go ahead and answer one question that I think actually will cover a couple of the questions that have come in since then. And that question came from Marcos. So the question is, how fast or easily can the multi-pipe unit alternate between cooling, heating, and simultaneous cooling and heating? So how fast or easily can the multi-pipe alternate between cooling, heating, and simultaneous cooling and heating? And this is, I think, key to the message we're trying to get across today. So let me see who I can choose for this, but I'm thinking Ronald, well, anyone actually could answer it, but who would like to take that one?
Yeah, I can take that one. I think, what is important here is that when you think about, let's say, heat pumps, so the ones that Dominique presented, or the multi-pipe units, to change, let's say, from one mode to the other, there are a couple of things which are really crucial. One of the crucial things is, let's say, what is called the four-way valve. So you are reversing the refrigerant flow. The other one is, let's say, the controller and algorithms that we have developed, let's say, for our unit controller. And those two together, with, of course, let's say, how much refrigerant is going on in, let's say, the piping, in the refrigerant piping, that determines how fast you can do that. And what we see with the fourth generation has a new controller, which is a proprietary Trane controller. We call it the Symbio 800. And with that one, and we are using that one also for, let's say, for the CXF multi-pipe units, we can pretty fast, let's say, transition from one operating mode to another operating mode. So it's just a matter of, let's say, minutes and not much longer. And then the unit starts to generate hot water instead of chilled water, or the combination of chilled water and hot water. So it's not a very slow system. It goes rather fast. And, you know, there's always inertia in the chilled water loop and in the hot water loop. So the customers, they will hardly notice, you know, that we are switching over the unit from one mode to the other. And we have, you know, every time we develop a new product, it's a very valid question. And this is one of the points that we are always, let's say, extensively testing in our laboratories to make sure, you know, that it functions very well and that it moves fast from one mode to the other mode.
That's fantastic, Ronald, and thank you for explaining it with such ease and knowledge. It does, Ronald, and I think there's a little delay, so thank you so much for answering that with such ease and knowledge. And Marcos is thanking you in the chat box as well, so thumbs up from Marcos. This brings us to the end of our Q&A session. I think there was maybe one other question that we didn't quite get to in the time we had allocated. So there is an invitation. If anyone would like to submit further questions, they can contact any of the panel members through their profile, which I believe the World Climate Foundation put together in the invitation. So you can contact them via LinkedIn profiles. And we look forward to connecting with you in the future, as it seems that all of the attendees today are very interested in this topic and in the future of how we together collectively can continue to decarbonize our economy and our cities for our future generations. So thank you for joining our sustainability journey. We're very proud of our team and everyone's contribution. And we look forward to seeing what other things we can do in the future when we challenge what is possible. Thank you and have a lovely evening wherever you are in the world.